Hello everyone. Today we will talk about the reflection of light. So first of all, we need to know the definition. When a light falls on a shiny surface, it reflects back in the same medium. Now, what is a medium? So we have three types of mediums: solid, liquids, and a gas. Now, as we can see in the diagram, we have a mirror and mirror has a shiny surface. Now we have an incident ray of light. So when the light is incident on this shiny surface, it will reflect back and it obeys the law of reflection. So we have two laws of reflection. The first one is that the angle of incidence. Now, what is the angle of incidence? Angle of incidence is the angle between the incident ray and the normal line. So this angle of incidence must be equal to the angle of reflection. So we have two laws of reflection. So laws of reflection. So the first law is angle of incidence should be equal to the angle of reflection, or in symbols we write it in this form. Now the other law is the incident ray reflected ray and normal all lie on the same plane. Same plane. Now, as you can see that this is your reflected ray and this one is the incident ray and this dotted vertical line is the normal. They all meet at the same point on the mirror. So this is the second law. Incident ray, reflected ray and normal all lie on the same plane. Now let's talk about the definition of normal. So normal, it is a line that is perpendicular to the surface. A line perpendicular to the surface. Now, what is angle of incidence? So, angle of incidence is actually the angle between the incident ray and the normal line. So, angle of incidence angle between incident ray and the. Now let's talk about angle of reflection. So angle of reflection is the angle between the reflected ray. This is the reflected ray and this is the normal line. So the angle between these two is called as the angle of reflection. So as you can see in these two diagrams that we are provided with a mirror surface and the two incident rays have been drawn and we have to complete the path for the reflected rays. So the first step is that we have to draw the normal line. So how do we draw the normal? So if the light ray is incident on the mirror at this point, so we will draw a line which is perpendicular to the mirror surface. So, so this dotted line represents our normal line. So let's mark the angle of incidence. So angle of incidence is the angle between the incident ray and this normal line. So based on this information, so this is going to be the reflected ray. And you can see that the angle of incidence and the angle of reflection, they must be equal. Now, similarly, so this is our diagram 1. So let us just complete the ray diagram 2. So this is the incident ray and the ray is incident on the mirror at this point. So we have to draw a line that is perpendicular to the mirror. So you can see that this line is perpendicular to the mirror. So this is going to be the normal. Now the angle of incidence between the incident ray and the normal, let's mark this angle. Now since the angle of incidence and the angle of reflection, they must be equal. So keeping that in mind, so this is going to be the reflected ray. And we can see that the angle of incidence and the angle of reflection, they both are equal. So quickly, so reflection of light, whenever a light falls on a shiny surface, the light bounces back into the same medium. So you can see that if initially the light was traveling into the air, then after it is reflected, it still reflects back into the air. Its medium does not change. We have two laws of reflection. First one, that the angle of incidence should be equal to the angle of reflection, where angle of incidence is the angle between the incident ray and the normal line, and the angle of reflection is the angle between reflected ray and the normal line. Now this incident ray, reflected ray and this normal, they all lie on the same point on the mirror. Now, the normal is always perpendicular to the mirror, and this is how we complete the ray diagrams. Now, let's design an experiment to verify that light obeys laws of reflection. Now, to do that, first of all, we take a plain white paper. So, this is a plain white paper. Now we will place a mirror vertically above this white paper. So this is a mirror that has been placed vertically above the white paper. We can draw the boundary. So this is the boundary of this plain mirror that we have drawn with a pencil, and mark the center of the mirror as point O. Now we will draw a normal line at the center. So we draw a normal So this is a normal line. So we can see that the normal line is perpendicular to the mirror. Now with the help of a ray box. So we have a ray box. Now ray box produces a single ray of light. So with the help of a ray box, we produce an we incident ray of light that strikes the mirror at point O. This is the incident ray of light and this is the ray box. So this ray box produces this single ray of light. So this is incident ray. Mark your incident ray as so this AO. Now, when this ray of light is incident on the mirror, it will reflect back. So this is the reflected ray. Now mark your okay. We will place crosses, two crosses on the incident ray and two crosses on the reflected ray, and we will join these crosses later. So here's a cross, here's another cross. So I am marking these crosses as P1, P2, P3, and P4. So we mark the crosses on the incident and the reflected ray. So when you remove when you remove the ray box, so you can join these P1s and P2 and P3 and P4 together so that we draw the incident and the reflected ray. So this OB is the reflected ray and this OA is the incident ray. Then later we mark the angle of incidence. So this is the angle of incidence and this is the angle of reflection. And with the help of a D or protector, we measure the angle of incidence and the angle of reflection. So this is how we perform this experiment. And then you can gradually increase the angle of incidence, and for each value of angle of incidence, you measure the corresponding angle of reflection, and you will observe that it always obeys the law of reflection because your angle of incidence will always be equal to the angle of reflection. Now let's write it in the words. So first we placed a plain mirror vertically on a sheet of white paper, and then we draw the surface of this plain mirror and we draw a normal at the center of this plain mirror. A ray box generates a ray of light that is incident to the mirror at point O. So this is clearly indicated on your diagram as well. So the light is reflected at the point O, and then we mark P1 and P2 on the incident ray, and we mark P3 and P4 on the reflected ray. Now we will remove the ray box, and once the ray box is removed, we will join P1 and P2 together to draw the incident ray, and we will join P3 and P4 together to draw the reflected ray. Measure the angle of incidence and the angle of reflection with the help of a protector, and we will observe that it obeys the law of reflection because the angle of incidence will always be equal to the angle of reflection. Now at the end we will repeat the experiment for 5 different angle of incidence and measure the corresponding values of angle of reflection, and it still obeys the law of reflection, and we will record these readings in a set of table with the following column headings. So we can draw a table as well. So we have angle of incidence, which is measured in degrees, and we have angle of reflection that is measured in the degrees too. So this is going to be the column headings for the table. And please remember when you give the column headings, so we always have to give the units with it as well. So both angle of incidence and the angle of reflection, they both are measured in degrees. So we can just put the symbol of degrees along with the column headings. So thank you so much.